Okay, hi, my name is Casey Shibler, and I'm doing a reassessment video on the magnetic fields standard. I want to start this video off by correcting what I had done wrong on my standard. If we look over here, as you can see, I did not denote this to be a vector as I had done down here, so all I did wrong was I forgot to carry up the fact that it was a vector. My mistake. For part B, I used the wrong location. It says, what is the magnetic field at the origin due to the electron? I accidentally used the location C instead of using the location of the electron, so I fixed it. I got my new R, which was the origin minus this location of the electron. R then was 5.0 times 10 to the negative third for the X location, then 0 and 0. I then did the dot product of the velocity times the, R. That gave me 0, so when all is multiplied out by 0, then the answer would be 0. So that means the magnetic field at the origin would be 0 due to the electron. To move on, I also completed 2 problems. The first being something simple, problem 41. A loop of wire carries a conventional current of 0.8 amps. The radius of the loop is 0.09 meters. Calculate the magnitude of the magnetic field at the distance of 0.32 meters from the center of the loop along the axis of the loop. After that calculation, it asks what would be the magnetic field of the magnetic field at the same loop, what would be the magnitude of the magnetic field at the same location if there were 100 loops of the wire in a coil instead of 1 loop. So I went and completed that over here. I have my equation for the magnetic field of a loop, which is the epsilon naught over 4 pi times 2 pi I squared, I being the current, R being the radius, and Z being the distance, plus R squared to the 3/2 power. So I have mu naught over 4 pi, mu naught over 4 pi equals 1 times 10 to the negative 7th terameters per amp. I then plug that in, and I get 1 times 10 to the negative 7th times 2 pi over 0.09 meters squared times 0.8 amps, then 0.32 squared plus 0.09 squared to the 3/2 power, giving me an answer of 1.1084 times 10 to the negative 7th tera for my magnetic field. Then it asks, what if there were 100 loops? Well, what you would do then is you would just multiply by 100, and that gives you the same answer, but down to 10 to the negative 5th tera. The second problem that I chose to do was to take that idea a little bit further. I chose to do problem 45. It shows a smaller semicircle connected to a larger one. It asks to calculate the magnitude and direction of the magnetic field at the center, right there. I have the image drawn out. Due to the current flowing in that direction, that means I could use the thumb rule or the right hand rule and curve. That means the direction will be pointing to the center or through the board in the z-axis, the negative z direction. It asks me to find the magnitude. It has been shown that the magnitude of a straight line actually has no effect to the overall, magnetic field. So it contributes nothing, because whenever you plug in your straight line sine of 180, you get all of this divided into 0, which is equal to 0. So we're left with trying to find the magnetic field of the R1 and R2 semicircles. So what I did is I have the magnetic field is equal to mu naught over 4 pi times I times d theta over R. Well, overall it's going to be equal to the magnetic field of the small semicircle plus the large. So you have mu naught over 4 pi times I pi. Since it's not a full circle, it's half, it's only pi instead of 2 pi, over R1 times the same constant with pi, because it's still a semicircle, not a full circle, over R2. So then you get B net is equal to mu naught over 4 pi times I pi times 1 over R1 times 1 over R2. And this is everything. Thank you.